Here are the notes for targets 10 and 11. Um, target 10 is I can list all the possible rational zeros of a polynomial and test them using synthetic substitution. So we're going to be listing all of them and then testing them. And we already know how to test them because we already learned synthetic substitution and synthetic division. So just moving on, looking at the first one, it says I can list all the possible rational roots of the given polynomial. So we're going to go ahead and first list all the factors of the last term, being 12. Then we're going to list all the factors of the first term, being 4. And then we're going to put those all together into fractions and create all the possible rational roots. So all the factors of 12, just start out with 1. 1 goes into 12, 2, 3 times 4 is 12, 2 times 6 is 12, and then 12 goes into 12. And then 4, 1, 2, and 4. So you need to know all factors of numbers as you go through this. And then it says all possible rational roots. So what we're going to do is we're going to take all of those blue numbers, which are the factors of the last term, and put them all over the factors of the first term. So we're going to put all lasts over firsts and create all possible rational roots. So all the possibilities of fractions. So we can't forget we have to do plus or minus with all of these numbers. We can have the positive or negative version of them. So starting, I'm going to say plus or minus 1 over 1, or just 1. You can either put 1 over 1 or you can put 1, whatever makes more sense. Then we have plus or minus 2 over 1, or just 2. Now if you notice, I'm going to keep going through this. I'm going to put all the blue over 1. I'm going to put all the blue over 2. Then I'm going to put all the blue over 4. And something else to keep in mind is that I'm not going to repeat numbers. So let's say I get, let's say 2 over 1 is 2, but then also 4 over 2 is also 2. I'm not going to write 2 twice, if that makes sense. So I had 2 over 1, which is 2. Then I have plus or minus 3 over 1, which is just 3, plus or minus 4 over 1, which is just 4, plus or minus 6 over 1, which is just 6, and then plus or minus 12 over 1, which is just 12. Now I'm going to move on to putting all those blues over the red 2. So let's see. 1 over 2 is 1/2, so I have plus or minus 1/2. 2 over 2 is actually just 1, so I'm not going to write that again. I already have that. 3 over 2 is 1 1/2, so we have plus or minus 3 over 2. 4 over 2 is just 2. I'm not going to write that again. I already have it. 6 over 2 is just 3. I'm not going to write that again. And then 12 over 2 is actually just 6, so I'm not going to write that again. So, moving on, I'm going to put all those blue ones over 4 now. 1 over 4 is 1/4. We don't have that yet, so plus or minus 1/4. 2 over 4 is 1/2. You don't have to write that again. 3 over 4, we don't have that yet. 4 over 4 is just 1. I'm not going to write that again. 6 over 4, let's see if that simplifies. 6 over 4 actually simplifies if I divide both those by 2. I get 3 over 2, and I actually already have that. So I'm going to go ahead and erase this. Don't need that again. And then 12 over 4 is just 3. So I'm not going to write that again. I already have 3. All right, so that was it. Plus or minus version of all of those numbers. Let's try another one. Looking at B, all the factors of the last term, meaning 6, and you can just totally disregard the sign attached to these numbers. And then all the factors of 3, which is the first term. Again, we're doing last over first in the last bullet point to get all the possible rational roots. So let's see, all the factors of the last term. So 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6. And then all the factors of the first term, just 1 and 3. So creating all these fractions is going to be a little bit easier this time. I have plus or minus 1 over 1, or just 1, plus or minus 2 over 1, or just 2, plus or minus 3 over 1, plus or minus 6 over 1. And then I'm going to put all of them over 3 now. So plus or minus 1/3, plus or minus 2/3, 3 over 3 is just 1, so I'm not going to write that again. And then 6 over 3 is just 2, so I'm not going to write that again. So here's all my possible rational roots. All right, now we're going to get into a little bit more depth using this. So it says list all the possible rational roots of the given polynomial and then test them using synthetic substitution. So listing all the factors of the last term, meaning 6. Let's see, I have 1, 2, 3, and 6. I already did that one. And then technically we have a 1 out front, so listing all the factors of 1, just 1. The only factor of 1 is itself. Listing all the possible rational roots. I have last over first, meaning all the factors of the last over all the factors of the first. Creating this fraction right here pretty much. I can do plus or minus 1 over 1, or just 1, plus or minus 2 over 1, plus or minus 3 over 1, and then plus or minus 6 over 1. There's nothing else I can do. Those are the only things I have. Technically, I have 8 options here. Positive and negative 1, positive and negative 2, positive and negative 3, and then positive and negative 6. So it says test roots using synthetic division. Well, we actually learned how to do this last class. So what we're going to do is we're just going to test all of these until we get synthetic division and we get a remainder of 0. So let's try one. I'm just going to start with positive 1. In my box, and then I have 1, 4, 1, and negative 6. So when I do synthetic division, I have to take all the leading coefficients and line them up right next to this little box. So 1, 4, 1, negative 6. Then I draw my line. I draw my arrow to indicate I'm just bringing down that first term. And then from here, I'm just going to multiply and carry over. Multiply and carry over, just like we did last class. So 1 times 1 gives me 1, and then I add 4 plus 1 to give me 5. Now I start over. 1 times 5 gives me 5. When I add those together, I get 6, and then 1 times 6 gives me 6. Well, when I add negative 6 and positive 6, I get 0. So yay! Remainder of 0, which means positive 1 is a factor. I'm sorry, is a root, a rational root. Alright, what I'm trying to do here is to get this here, which they gave me, which is a degree of 3. I'm trying to get that to a quadratic because I can factor quadratics, and I can use the quadratic formula on quadratics. All I'm trying to do is take one of those rational roots out of there to bring it down to a quadratic, which I did. Since positive 1 was a rational root, I'm going to list it down here. X equals 1. I know that for sure. Now what I'm left with is 1x squared plus 5x plus 6 with no remainder. So I'm actually just left with x squared plus 5x plus 6. And what I'm going to do from here, because it's a quadratic, is if I can factor it, I'm going to factor it. If not, I'm going to go ahead and use the quadratic formula, or, you know, whatever works, whatever you can do. I can actually factor x squared plus 5x plus 6 because the a value is 1. So let's see. Factors of 6 that add up to be 5. I'm just going to list them off to the side here. I have 6 and 1. I have 3 and 2. They both had to be positive or both negative to get to a positive 6 when I multiply. And then I'm trying to get to a positive 5. I'm going to use 3 and 2. So because my a value is 1, I can skip to this quick step here where I do x plus 3, x plus 2. And there's pretty much all of my factors now. So my rational roots are going to come from me actually solving for x here. X plus 3 equals 0. I subtract 3 from both sides, and I get x equals negative 3. And then x plus 2 equals 0. I subtract 2 from both sides, and I get x equals negative 2. So x equals 1, x equals negative 3, and x equals negative 2. Those are all my rational roots. I am done. All right, and that's it. You're always looking for 0 as your remainder when you do the synthetic division, trying to get all the rational roots. And also, you're just trying to bring it down to a quadratic. You're trying to bring it down to this step right here so that you can jump into your factoring or quadratic formula or whatever you need to do. All right, let's go ahead and move on to the next target. That was target 10. This is target 11. I can rewrite a polynomial in factored form using synthetic division and other factoring methods and find all zeros. All right, so looking at A, it gives us x cubed plus x squared minus 14x minus 24, and it tells us one of the factors is x plus 2. So what I'm going to do is I'm going to take the rational root from the factor of x plus 2, which is going to be negative 2, it's just the opposite sign, and then I'm going to test it in synthetic division and bring it down to a quadratic. That's kind of the general overview of what I'm going to be doing here. Now, to get from here to my root, I just actually set it equal to 0 and solve for x. If you notice, I'm just going to be subtracting 2 from both sides to get x equals negative 2. So that's what I'm going to test using synthetic division. So I'm going to put negative 2 in my box, and then I'm going to list all of my leading coefficients. If you don't want to do this math off to the side here, if you can just remember that it's always going to be the opposite sign of whatever is in the parentheses, it'll make your life easier. So I have 1, another 1, negative 14, and then negative 24. Getting a little cramped there. I'm just going to erase it. Alright. Draw my line, bring down my first number, and start multiplying. So negative 2 times 1 gives me negative 2. When I add those together, I get negative 1. Negative 2 times negative 1 gives me positive 2. When I add those together, I get negative 12. And then negative 2 times negative 12 gives me positive 24. When I add that to negative 24, I get 0. So yay, that worked. I got a remainder of 0, and now I can rewrite as a quadratic here. So this quadratic is x squared minus x minus 12. Now I got those numbers by just bringing down the coefficients. What I'm left with, these numbers are telling me, is that's the coefficient of x squared. That is the coefficient of x. That is the constant that I have left. Okay, just like on the previous slide, that's what I was left with. If you take a look here, when I did my synthetic division and I was left with this step right here, positive 1 was my coefficient of x squared. Positive 5 was the coefficient of x. And then 6 was my constant. So, looking at this, that's exactly what I'm doing here. The numbers that I have left over are just the coefficients of my new quadratic. All right, so now I'm going to actually factor this, if I can. Any factors of negative 12 that add up to be negative 1. 3 and 4 would probably work. One of them has to be negative, and in order to get a negative 1 when I add, my 4 is going to be negative. Because my a value is 1, I'm just going to skip to this form of factoring here, x plus 3, x minus 4. All right, and then it says it wants me to give the factored form and the zeros. So my factored form is actually just going to be combining what they gave me was one of the factors, and then the rest of what I got. So my factored form completely is going to be x plus 2, x plus 3, x minus 4. And then the zeros. I'm going to take all those factors and just set them equal to 0 and solve for my x, pretty much. So x plus 2, I already did that. When I solved for 0, I get x equals negative 2. X plus 3 equals 0. I subtract 3 from both sides. I get x equals negative 3. And then x minus 4 equals 0. I add 4 to both sides. And I get x equals 4. So my zeros are x equals negative 2, x equals -3, x equals 4. Synthetic division is just a way of taking out one of those factors and being left with a polynomial of a smaller degree. So if I'm given a polynomial with a degree of 3, which they gave me, I'm just breaking it down, bringing it down to a quadratic, and then factoring from there. So it's pretty much just like taking it apart for me. So let's look at B. They give me a quartic, actually. They give me the highest degree is 4, so we might have to do this twice. So they actually gave me 2 factors that are going to work, which is actually really nice because I can just use those to do synthetic division twice. I'll start with the x plus 2, which means I'm going to put -2, always the opposite sign, in my box, and then I'm listing all of the leading coefficients after that. So I have 1, -2, -15, -4, and then 20. Drawing my line, bringing down my first number, and we'll start multiplying. -2 times 1 is -2. When I add those together, I get -4. -2 times -4 is +8. When I add those together, I get -7. -2 times -7 is a +14. When I add that to -4, I get 10. And then -2 times 10 is -20. Added to +20, and I get 0. So I got 0 as my remainder, which means x plus 2 is a factor, which means -2 is a 0. And then I'll do synthetic division again, but what I'm going to use this time is my new polynomial. So I started with x to the 4th. After I did synthetic division once, I'm left with x cubed as my highest degree. And don't forget, all of these numbers here are the coefficients of my new polynomial. So I'm starting with positive 1x cubed minus 4x squared. I'm just taking those numbers from right above it and writing them. Minus 7x plus 10. There's my new polynomial with degree of 3 now. Now I'm going to use synthetic division again, this time using my x minus 1 and trying that. So I'm putting the opposite sign, or +1, in the box, and I'm going to write all of my leading coefficients right next to it. So I have 1, -4, -7, and then 10. Bringing down my first term, 1 times 1 is 1. Add that to -4, I get -3. 1 times -3 is -3. When I add that to -7, I get -10. -10 times 1 is -10, and when I add that to +10, I get 0. So that one worked as well. Now what I'm left with, since I moved it down from a x cubed, I'm left with an x squared or a quadratic, which is perfect. Now I have x squared minus 3x minus 10. Let's see if I can factor that. Any factors of -10 that add up to be 3? So I have 10 and 1, and then 5 and 2. One of them has to be negative, so if I do -5 and +2, I can add those together to get -3, so that'll work. My a value is 1, so I can do x minus 5x plus 2 and just skip to that step. All right, perfect. So my factored form, don't forget, it's a combination of what they gave me and then what I ended up with after I factored. So they gave me x plus 2, x minus 1, and then I ended up with x minus 5, x plus 2. If you notice, I have x plus 2 twice. So when I write my zeros, I'm actually going to show you a little bit of a quicker way to write those. I'm going to solve down below because I wasn't left with much room. X plus 2 set equal to 0. I just subtract 2 from both sides. I get x equals -2. Now I have it twice, which means I'm actually just going to write multiplicity 2. And then x minus 1 equals 0. I'm going to add 1 to both sides. Get x equals 1. And then x minus 5 equals 0. just going to add 5 to both sides to get x equals 5. All right, and there you have it. That is the notes. If you have any other questions on synthetic division or substitution or writing out the factored form or the zeros, just ask your teacher or one of the Algebra 2 teachers. All we want when we're finished with this is the total factored form, so the combination of what they gave me and what I ended up with when I factored my quadratic, and then setting all of those factors equal to 0 and getting my x values or my zeros. All right, and that's it.